Hello and welcome to the session. Is your network ready for Teams? In this session, I will talk about Jitter. In previous sessions, we talked about latency and packet loss. So latency, just to recap, is the time it takes to send the packets from source to destination. Packet loss, when the packets are lost or dropped between two endpoints. Jitter is when the packets arrive in the wrong sequence. They arrive to the destination out of order. Think of jitter as a variation in your latency. It represents how consistent your delay is. So let's take an example. If your average ping time is 50 milliseconds, the first half of your packets arrive in 30 milliseconds, and the second half arrive in 70 milliseconds. So your average jitter is 20 milliseconds. If I look at the diagram here, you look at the top one here, the packets. So we have the latency, we have the delay, which is normal here. So we have low jitter, and this is fine. This is acceptable by Teams. We're going to look at the thresholds in a second. So just low jitter. This is fine. You can deal with that. Now, if you look at the bottom one here, so this is jitter and this is high jitter. Think of the examples we just explained. So let's say this is 30 milliseconds. This is 70 milliseconds. So this is high jitter. Now Teams has a jitter buffer which is used to reorder the packets into the original sequence. So Teams deals with jitter by having this mechanism, this component of jitter buffer, and its main task is to reorder those packets in the right sequence. If I look at the symptoms of jitter, the jitter buffer increases latency. So the buffer has a queue, it has a waiting time. So the more jitter, the more processing that buffer needs to do, this increases latency, and this is going to lead to the same symptoms as latency. An example of latency, the symptoms of latency, is when people talk over each other. The other one is if packets arrive too late, they are dropped, and this is going to lead to the same symptoms as packet loss. So packet loss, if the packets are lost, so we'll have broken audio, frozen video, fragmented video. So these are the symptoms of jitter. Now, how do we limit jitter? We can reduce the network congestion, properly implement quality of service, or we can increase the bandwidth on the network. Let's now jump to understand how much jitter we can allow in the Teams environment. So this is my Teams client. This is my Edge, public internet, Microsoft Edge, Microsoft Network, and then this is my Teams servers, backend, transport relay, media servers, and all of that. So from the client to the Microsoft Edge, this is less than 30 milliseconds, so jitter in milliseconds, so less than 30 milliseconds during any 15 seconds interval. 30 milliseconds during any 15 seconds interval. If it's from your customer Edge to Microsoft Edge, this is 15 milliseconds during any 15 seconds interval. And finally, let me jump to the Teams network assessment tool to check for jitter, packet loss, and latency on my network. So if I end the show, let's just go here. So if I run this tool, which is the network assessment tool, the Teams network assessment tool, and the command is network assessment tool.exe/quality check. We just run the tool on my network, my home network, and this is basically going to do the RTP packets to my Teams backend servers. So you can notice here loss rate is 0, latency is 19.13, and jitter is 15.914. So I'm within the threshold, the range. Remember, from Teams client to the Microsoft Edge server is less than 30. So I'm within the threshold. Packet loss, this is, I believe, should be in the range of less than 100. So I'm okay there as well. And packet loss or loss rate is 0. So I'm good for my audio and video calls on Teams.